Finiku. Physics fundamentals. Today we are going to discuss commutative properties and how they work. We'll go over definitions and give some examples of commutative properties and when they can be used and how it will make practicing physics simpler. After that, we were going to go over and review formulas and definitions of physics, talk a little bit more about relativity, and then we'll explore other universities of physics. We are working in quantum physics. We talked about thermodynamic physics, and we'll just kind of refresh ourselves on thermodynamic physics and introduce information on quantum mechanic physics. So you will need to know at least 3 universities of physics. For the purpose of this class, we are working in quantum physics. Now let's talk about commutative properties. Commutative property is a way to gather numbers that will create the same outcome if switched or moved around, so that the actual answer would still remain the same and true if the numbers were rearranged. This is known as commutative properties. So let's see some examples of commutative properties. 3 plus 2 is equal to 5. This is true. What is also true is that 2 plus 3 is equal to 5. This is commutative properties. Again, you can see the same with the forks. And this time we are multiplying. 3 times 2 is equal to 6. And 2 times 3 is equal to 6 because there's 6 forks. And 3 times 2 is equal to 2 times 3. This is commutative properties. When we are multiplying with commutative properties or adding, if something occurs in the parentheses, we always start with the numbers within the parentheses. So, in this case, 6 times 9 is in the parentheses, and so we would go to 6 times 9. And when we go 6 times 9 is equal to 54, then we could say 54 times 4 is equal to 216. Now the bottom math problem says we should go to 9 times 4 first, because 9 times 4 is in parentheses. And 9 times 4 is 32. And then we would multiply 32 times 6. And it again would give us 216. Let's go on to formulas. We talked about formulas. We showed you some different formulas. And we're going to give you a definition. Newton's second law is F is equal to ma. And this says that force is equal to mass times acceleration. And this is one of Isaac Newton's formula to his second law. And the second law again is F is equal to ma. And this formula states that force is equal to mass times acceleration. This is a gravitational force. F is equal to G astral parenthesis mf asterisk m2 parentheses. This was a formula that Isaac Newton had come up with. So this formula had to do with gravity. Again, remember, physics is a study of how the universe behaves. Physics is a natural science that involves the study of matter and its motion through space and time, along with related concepts. So remember the definition of physics and have an idea of what physics is, and then do not forget relativity. Relativity is the non-quantum theory of gravitation. So we are going to ask about general relativity, and you are going to give us the answer. It is a theory and a concept that's developed by Albert Einstein and is related to the idea of gravity, relativity. You also will need to have an understanding of thermodynamics. And what is thermodynamic physics? We will be looking for a definition for thermodynamic physics. In thermodynamics, energy is transformed without creating or destroying it with the help of physics. And again, it is physics that use temperature. What does the study of physics entail? The study of physics involves numerous topics such as thermodynamics and classic mechanics and relativity and quantum mechanics. Quantum mechanics. Quantum mechanics is another university. It appears as mechanics. So I will accept I will accept universities or branches of physics. And this is one university or branch, mechanics physics, and quantum mechanics physics or mechanics physics. And we are going to learn a little bit about quantum mechanics. So let me give you a definition, because we talked about thermodynamics. Quantum mechanics path integral formulation scattering theory. Its equations of quantum field theory and quantum statistical mechanics. So mechanics theory is, or mechanics physics is a formulation of scattering theories. So it's integral, meaning that it goes line by line by line. This particular way of operating under mechanics physics. So again, mechanics physics is another universe or branch of physics. And there are several branches and universes of physics. We have mentioned three: mechanics physics, quantum physics. Mechanics physics can be referred to as quantum mechanics physics. And then you have quantum physics. And we also have discussed thermodynamic physics. So you will need to know at least three universities of physics.